So I've actually got two talks here back to back. First one I have here is all about the future of TypedDict. So just briefly, in case anyone came in a little bit late, I'm David Foster. I did the initial implementation of TypedDict, and I'm generally shepherding related features to it at this point. And when I'm not doing open source things, I am the CTO at TechSmart, and we are inspiring kids to code in the K through 12 space. So I thought it might be worth briefly reviewing the history of various features that are related to TypedDict. It was originally introduced with just a functional syntax, and then later on a class-based syntax was added, which I think is the kind that most people are using at this point. At the same time, we got the ability to declare TypedDicts with total equals false, which means that all the keys for it are not required. And just recently, with new PEP 655, we have the ability to declare individual keys as either required or not required. So that's where we are right now. So there are a couple ideas for things to add to TypedDict in the future. These have been proposed on the Typing SIG mailing list and in some cases other places such as issue trackers and similar. I thought that it would be interesting to just give a review of what these types of extensions might look like. And yeah, so let's get started. So one thing that is a bit of a pain point with TypedDicts is at least with MyPy, you can't have a recursive definition of TypedDicts. So common cases, if I'm trying to, in this example, make a structure that's like a file system, I can't have a directory that contains other directories. But if we were to add support for recursive TypedDicts, then this would be okay. At this point, currently, this does not work as far as I understand. So recursive TypedDicts. You'd think it would work, but, oh, I see a question.
What is typed JSON?
Typed JSON?
Like the JSON type, is that something?
Yes, it would make a typed JSON type more feasible than it is right now. There may be some other challenges with that, but it's probably a prerequisite for a better type on that.
Do other type checkers support this, or is it just a MyPy limitation that MyPy doesn't support recursive types very well?
I do not know if other type checkers support it or not. I'm hearing from the audience that Pyrite does support recursive TypedDicts already, so cool. More things that we could do. So another idea is, so right now, if you declare a TypedDict with a particular set of keys, because the standardized form of TypedDict in, I forget the PEP number, the standardized form allows subclassing of TypedDicts. It will actually allow you to add keys at runtime to a TypedDict value that aren't in the original definition. So TypedDicts are open by default. But there may be some cases where you want a more strict usage of TypedDicts such that, for example, with, in this example, we have a point2d that declares only an x and y key. But at the moment, if you were today to try to set an additional key z on it at runtime, that would actually work. But you might not want it to work. So an idea is there might be some way to declare a TypedDict as being closed. Here, just a provisional syntax idea is maybe use the final keyword or the decorator on a TypedDict definition, which would then mark it as being closed. So I thought this was an interesting idea. Next one up is something that's a little bit similar, read-only TypedDicts, which is, So right now, a typed dict is a dict, and because dicts are mutable, you can change them after construction, but sometimes it might be useful to have a read-only type of typed dict. So right now, the read-only version of a regular dict is called a mapping. So I was like, well, maybe we would call it something like typed mapping if we wanted this type of support. So I think this is kind of interesting. And another sort of, see, I'd have to review my type theory, but because this is a immutable type, there may be something that can be invariant here that wouldn't be possible in other cases. So there might be some interesting uses for that. So that's read-only typed dicts. And the fourth idea, which was actually mentioned earlier during the summit, was adding support for generics in TypedDict. So this is, for example, a point 2D where you could instantiate it with an int parameter, so it's an xy integer coordinates, or you could instantiate it with float, so it's an xy of float. And so, again, I guess this is actually provisional syntax as well, but it seems like this would be the sort of the obvious syntax, and in some cases you may even want to have, say, like a type alias that is using these integer or these generic parameters, and then you could instantiate the alias, which would be kind of interesting. That's not something that would be a straightforward thing to support, at least in my Py. So so that would definitely require some thought on the specific syntax and then implementation difficulty and similar. But this does seem like something that may be desired, and it was even mentioned, as I said earlier. So yeah, that is just a couple ideas. So I think a number of people in this room are probably already subscribed to TypingSig, and these are just ideas. Like, I'm not saying that I'm personally going to implement all of them myself, but I'll definitely provide some support. But yeah, anyone who's here and who's interested or who's watching at some later point, yeah, love some help on making TypedDict better. Put some designs together, put some PEPs together, write some code, it'll be great. So yeah, I think I've got a couple minutes for questions. All right, let's see one right here. Oh.
Are TypedDicts the canonical way to do some types in Python?
Some types, let me think. I think, so the question was, are TypedDicts the canonical way to do some types in Python? And I think that would be a union type is what you're looking for.
So union is one of the, right? Like at some type, I want to have like a some type include multiple things.
Some type to include multiple things.
So are TypedDicts the canonical way to do
Product types.
Those are immutable?
So let's see, so a product type could be done with a typed named tuple, which is the capital form of named tuple. So that might be what you're looking for there.
Then it's immutable, right?
Correct, it is immutable in that situation.
You could also use a data class that is immutable if you want immutable.
Let's see, I think I've got another minute for questions. So one in the front here.
Excuse me if this is a dumb question, but is there a way to declare the type of everything else you add? So like you said Z in your example, everything else, is that possible? And if not, is it a consideration?
So I believe the question was, if you have just a regular TypedDict, can you add Z on to the end of it just in today's syntax?
Can you restrict the type of Z? Can you say, like on a tuple, you can say
Oh,
dot, dot, dot?
Yes, you can do this. So if you know in advance that there could be a Z key added, and you knew that, for example, that it needed to be of typed int, you could use the not required key to declare that.
Anything new.
So you're saying, okay, so is there a way to declare that for any unknown key added to a TypedDict that it must be of a particular fixed type, there's no current way to do that that I know of, and I believe there was something proposed on a typing sig thread that was like along the lines of this.
Yeah, there was a thread about this. It's possible to do if we have, you have to make it final to avoid a collision with subclassing rules.
Okay.
We would need a PEP for it, and we need to figure out what's the best way to specify the type, which could interact with the rules for scoping on generics. But it should be possible if we have a use case that needs it.
Okay. Sounds like this capability could be added, but it might also be a little bit tricky, so probably a PEP or similar would be required. So,
If you're in control of your data, the thing that works really well for it is just nesting all the unknown stuff in a register.
cool. Well, that's all I've got for this little talk right here. So thanks for listening for that first bit.